All right, this is 512. There's some quick problems for you to try, practice, and then find the area and perimeter of each rectangle. This will show up on that next test, okay? So very quickly, this is an 8. What is moving here so much? An 8 by 5. Whoops, that's a horrible 5. 8 by 5. And the perimeter then is 8, 8, and 5. We add all of those up. And what do we get? We get 26, right? 26 what? Oh, 26 units. What's the area, right? Well, in this case, we multiply 8. We can count each individual square unit in there, and that would be kind of long and time consuming, but we can just simply say 8 times 5 to get 40 square units, okay? On the right, what do we have for perimeter? Again, we have 3, 11, 11, and 3, and we add up all of those, and we have 28 centimeters, and our area in this case is 3 times 11, which is 33 square centimeters, okay? All right, so today we're going to work on 512, and we're going to use models to multiply fractions. Grant, Oliver, and Sonia were working on solving the problem below. Jenny's house is 4/7 of a mile from the bus stop. If Jenny had to run 2/3 of the way from her house to the bus stop, what portion of the mile did Jenny run? Grant drew this diagram to visualize this problem. Use his diagram to determine what portion of the mile Jenny ran. Okay, so what is he representing right here, right? What's he trying to show? Well, what I noticed that there are 7 there, and he has 4 of them shaded. I think he drew the 4 sevens from there. So then how could we represent that 2/3? Well, that goes back to our brownie pan situation that we had yesterday, right? We divide that into thirds, right? And then what we say is, oh yeah, Jenny ran 2/3, so 1, 2/3, right? And then what we do is we're going to count all of those individual pieces in there to help us find the area, right? And so we look for those that are double shaded, right? So we have 1, 2, 3, 4, 5, 6, 7, 8. 8 of those are shaded, and 8 out of how many? Well, that's 3 times 7, which is 21. So I'm going to erase this just because it's hard for me to do that later. So we had 8 of those. 8 out of 21 total pieces. And where did that come from? Well, we know that this is a 3 by 7, so we have 21 total rectangles inside. Okay, 8 21sts. All right, so practice Grant's method down below. You, when you, very quickly to practice, I would pause, try this on your own, and then come back. All right, when we say 3/5 of 2/7, I'm going to be very quick because you should be just checking your answer. 1, 2, 3, 4, 5. So 3/5 is 1, 2, 3. And then 2/7 is 1, 2, 3, 4, 5, 6, 7. And we do, in this case, 2/7, 1, 2. And how many are shaded? 1, 2, 3, 4. Whoops, 5. And I missed those. 5, 6, right? So this is 6ths. 6 out of how many? Well, we could count all those. That is a 5 by 7, so 35, right? All right. Half of a 10th over here on the left side. We can draw this one again. And I'm going to draw this one pretty large. There's a half, right? And then we're going to have to do a 10th. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And how many of those were shaded? 1/10. So let's shade 1/10 down here. How many? That's 1 that's shaded out of all that. And how many pieces? 1 is shaded out of how many? 2 times 10, which is 20 total pieces. Okay. All right. Oliver was working on that same problem, but drew a different diagram. Okay, so the same problem we're talking about is Jenny's problem here. Okay, so, all right, so Oliver, but he drew this different diagram. 4/7 a mile, but ran 2/3. 4/7 of a mile, but ran 2/3. Okay, so what we can do is we had to divide this part, or this rectangle up here, into thirds, and then we shaded each part. So let's do that same thing here. Let's take and divide each of the pieces into thirds. And while we're doing that, we will have to shade how much of each one? 2/3 of each, right? 2/3 of each. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I don't know why I'm counting all of those, but I am. There's 2/3 for each of those. How many are double shaded, right? They're shaded with the 4/7 and the 2/3. 1, 2, 3, 4, 5, 6, 7, and 8. So we have 8 out of how many pieces? Well, we have 3 for each one, right? So we have 3, 6, 9, 12, 15, 18, 21. 8 21st. And if we look, that's the same answer that we got up here, right? So, that just kind of verifies it, but this shows a different method or a different way to do that. Grant has that rectangular one, which kind of works out nice, but sometimes this circular type one works really well. So what we're going to do is you're going to do Grant's method, just like this, or no, I'm sorry, you're going to do these exact same problems, but you're not going to do them now with Grant's method, you're going to do them with Oliver's method. And we should expect 6/35 and 1/20. And let's go check. All right, so let's practice Oliver's method. And what we'll do is we will take 3/5 of 2/7. So I'm going to draw 1, 2, 3, 4, 5, 6, 7, and I'm going to say that 2/7 is right there. And then what we have to do is do 3/5. So dividing this into fifths is probably not going to be super pretty. Oh, that worked. And we'll do that for each one. And I know this seems tedious, but what it is really nice for us to kind of verify that we can do that exact same problem just a little bit different, right? So 2/7, right? So 1, whoops, that's not actually a bad idea, but I'm going to go 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. And again, we're looking at which ones are double shaded. 1, 2, 3, and 4, right? So how many do we have? We have 4 out of what? 35 pieces. Is that what we had from up above? Let's check. Oh, 6. We should have 6. What did I mess up? 3/5 of... Oh, that's because I never did the 3/5. Did I? I did 2/5. There's 3. And I got to shade each of those in. Mr. Crone. There we go. 5 and 6, and that would then change this to 6. Good thing we had a chance to go back and check, right? Not good. All right, let's try Oliver's method, but let's hopefully do a much better job here with a half of a tenth. And what I would suggest is, in this case, because 10 is such a large number and it's very hard to divide each circle into tenths, I'm going to draw the 10 circles, 3, 4, 5. 1, 2, 3, 4, 5. We only have to shade 1/10 of that, right? So that's this. And then we're going to divide each of those in half. 1. And we only shade a half of that. So here we go. 1. Whoops, sorry. 1, right? And only a half of that, right? So again, which one is double shaded? Just 1. 1 out of how many pieces? 1/20. Let's verify that Mr. Crone did it right this time. Hey, 1/20. Way to go. All right, so let's do Sonia's version, right? So Sonia also is doing the running part, and she drew a totally different diagram. Her method is shown below. Remember, it's 4/7 a mile, but ran 2/3. You can see the 4/7, and what we'll do is we're going to divide. This one's a tough one. You want to kind of divide some stuff into 2/3, but notice here how we took each circle and like here, we took each circle of those and divided into thirds. And when we took here, we had 7 pieces, but then we divided that into thirds. So each piece became 3 pieces, right? So if we take a look at that bottom one, right? It was once 1 piece, now it's 3 pieces. We once had 1 piece, but we divided into 3 pieces. So we're going to do the same thing. This first one is 1 piece. We need it into 3 pieces. 3. And just like if you could picture each one of these as being a circle, right, a part of that circle or whatever, or each circle or whatever, and we took and we broke each one of those down, right? So let's find the 2/3. So 1, there's the 2/3. And what did we end up getting? Well, we ended up getting 1, 2, 3, 4, 5, 6, 7, 8. I don't need to count those, right? Because those aren't double counted. So I have 8. 8 out of what? 8 out of, and we can count each one of these, 3, 6, 9, 12, 15, 18, 21. And let's double check. 8 21s. All right, we're going to practice the 3/5 of 2/7 and half of 1/10, but we need to use it with Sonia's method. I didn't give myself a ton of space, did I? All right, so here we go. Let's do 2/7 first. 1, 2, 3, 4, 5, 6, 7, and we had 2/7, so that's right there. And then we're going to do 3/5 of each. So we got, let's choose a different color here. 1, 2, 3, 4, 5. Did I do that right? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then let's do our appropriate shading in here. I wonder how well yellow will show up in here. 3/5. All right. Oh, that might be okay. 1 there. And all we're going to do is hopefully verify what we were doing before. Oh, I ran out of room. I don't have a lot, do I, in there? Okay, let's double check. Let's see how we did. We have 3, 1, 2, 3 here, 4, 5, 6 here, and that's it. So we had 6 out of. We could count each individual one. We should have 35. Did I do it right this time? Hey, 6/35, much better. Let's try this method. 1/2 of 1/10. So let's take and draw our thing here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we had 1/10 of that. So there we go. And then we did 1/2 of that, right? So we can divide each of these tenths in halves, which will then give us a total of 20 pieces, right? 20 pieces total. And how much of those are double shaded? Let's check. That would be right there. So 1 out of that. Whoops, I never did shade the rest, right? Because we're shading 1/2 of that, right? All right, and what is now double shaded? 1 out of that, those 20 pieces, okay? So whose method do you prefer? Grant's, Oliver's, Sonia's? That's totally up to you, but there are times when both methods, or each method, might work a little bit better, right? Grant's might be easier to write, but Oliver's might be easier to represent with those circles, and sometimes Sonia's method, all kind of drawn out into a line, works better. And the nice part is everybody has a unique view on this. So, if you have any questions, let me know.